So let's have a look at the Atlantic Ocean again. Okay. So now you look at 3 different cakes of the Atlantic Ocean. You have a temperature cake, which is the top part, and you just cut it in half and open it. Okay? South Pole is on the left, North Pole is on the right. You have a salinity cake, which is the middle one, and you have a dissolved oxygen cake. And that's something new. Dissolved oxygen, which in units of milliliters per liter. So how much dissolved oxygen is in there? Okay? And you can see different type of structures. Okay, temperature, we already talked about that. It's not a big surprise. You find warm water in the warm water regions. So you see warm water near the surface, the permanent thermocline underneath, and so. Where it becomes more interesting is the salinity structure. Okay, have a look at the green tongue of Antarctic intermediate water that you can identify. Okay, it's actually a salinity minimum. You can imagine that if you do measurements in the vertical, at some depth of around 1,000 meters here, you actually find low salinity water. It's a local salinity minimum. The North Atlantic deep water, for example, you can identify by a salinity maximum, by a local salinity maximum. And this is how you can trace water mass. This is because essentially it's both temperature and salinity, but salinity gives you the clue. Okay, salinity tells you who's the murderer. Okay, so now I show you also dissolved oxygen distributions because there is dissolved oxygen in the deep sea because of these currents that you create, and there's very little consumption at depth. And to also introduce you to something which is called oxygen minimum zones. Okay, and if you have dissolved oxygen maps in these units, milliliters per liter, then there are so-called dead zones, and it's actually the dead zone is more like less than 2 milliliters per liter. Okay, is a dead zone. And there's an indication here near the equator that this is a region where you have relatively low oxygen levels in the Atlantic Ocean. So sort of just in lower parts of the permanent thermocline. Okay. Whereas all the deep oceans, there's plenty of oxygen there. There's no oxygen limitations in the oceans and in depth of 5,000 meters. Okay, because you have the continuous. It's very slow, but you have the continuous supply of waters rich in dissolved oxygen and very little consumption in the deep sea. So what else is mentioned here? Water masses can be traced. You can see the naming. Okay, this is the Labrador seawater. You can even, when we talk about the details in tomorrow's lecture, so some of the water of the North Atlantic deep water is formed in the Greenland Sea, and some is formed in the Labrador Sea, and you can even distinguish them. Okay, that's an interesting feature. Okay. Mediterranean water we can identify here. What else is in here? Okay, upwelling of North Atlantic deep water in the Southern Ocean. You can identify that. I just mentioned it. We come to that later on. Okay.